I'm Annalisa Arcella, and today I'm going to talk about energy consumption. At first, I would like to start with a question. It's me. Which use the most energy? To prepare a dinner for your beloved, to get beautifully scented clothes, or to have a wonderful, relaxing bath? Who thinks that is the first? The second? The third bath? Amazing. Actually, the winner is the hot water, but if you look at the data, they cost practically more or less the same. Apparently, people don't know how much energy they consume every day, and we don't know exactly how much is to prepare a dinner, a coffee, or to watch TV. For my project, I worked with Voltaware. Voltaware is a company that develops smart devices for energy calculations and monitoring. They develop a sensor that is installed close to the energy meter of your apartment, and the transmitters connect securely to your local Wi-Fi network and start sending live data to their servers, and the data are analyzed by using artificial intelligence technology. To compute the energy consumption takes just a couple of hours, and finally, thanks to a user-friendly app, you can have information about the energy consumption of your apartment. Amazing! But if we really want to change our habit to save money and to respect the environment, we need the breakdown of the energy consumption. We need to have a precise information about how much energy each appliance is consuming. For my project, I developed a pipeline to compute the energy consumption of the boiler. To outline my work, at first I filtered the boiler signal, the electrical boiler signal, and then I applied unsupervised machine learning algorithm to compute the energy consumption of the boiler. The data were collected by installing hundreds of sensors all over France. This is the electrical signal of each produced by each sensor in one day. In black is the electrical signal of all appliances, and in boiler is my filtered signal. The energy consumption of the boiler is simply the product of the power of the boiler times the time range during which the boiler is on during the day over 1 month. I applied the DB-scan clustering algorithm to identify this time range that corresponds to the length of the cluster. My model produced for a warm month, September, a cluster of few scattered points during the night with a turn on at 1 p.m. And a few scattered points means that the boiler is on not every day, but only for a few days. In a colder month, October, I have the appearance of a first dense cluster during the night with a turn on at 1 a.m. And the dense like September. But an increase in density of the cluster means that the boiler is on most days in a month. Finally, for December, in a cold period, I can identify 3 dense, well-defined clusters. One during the night with a turn-on at midnight, the second one during the morning and afternoon, and the smaller one during the evening. This result means that the boiler in the winter is on every day during the whole day. All this information will appear on your mobile to have a full monitoring of the consumption, the energy consumption of your boiler. What's the impact of my work? Smart meters help consumers to reduce energy bills by 2%. If we take into account that the boiler covers the most of our bills, the 2% is a huge saving. 2% means a saving of £200 million across the UK, and up to 60% of less of carbon emission. Within this impactful scenario, my model will be deployed in the Voltaware Smart Energy Monitoring by the end of March. And hopefully you will see my results on your phone. And hopefully my 8 weeks project will have a good impact on your saving. Thanks for your attention.